In section 2.2, we're now going to cover the integers. But before we move on to the integers, let's discuss the set of whole numbers. If you remember, in the preceding section, we talked about the natural numbers, which are also referred to as the counting numbers. The counting numbers start at 1, 2, 3, 4, 5, etc. When it comes to the set of whole numbers, this will also include the number 0. So the whole numbers are 0, 1, 2, 3, 4, 5, and then goes on forever. The only difference between the natural numbers and the whole numbers is the natural numbers do not include 0, whereas the whole numbers do. The easiest way I find for students to sometimes remember this is if you look at the word natural, there's no O in it. So no O, like no 0, means no 0 in the natural numbers. But for the whole numbers, if you look at the O, it kind of looks like a 0. So the 0 is a part of the whole numbers. If we consider negative numbers or the opposite of each of these, and we add them to the set, then we get a set called the integers. So the integers is the set of whole numbers as well as their negatives. So the integers include 0, 1, 2, 3, etc. But they also include -1, -2, -3, etc. The set of integers is a set we're going to use a lot in this class. And this is going to be very important, but now we want to know how to kind of do operations with these. And again, for us, the 4 main basic arithmetic operations are addition, subtraction, multiplication, and division. When we're adding two numbers with the same sign, we add the values, meaning we add the absolute values of the two numbers, and then we keep the common sign for the answer of our sum. For example, maybe I'll jump over here to part C, but just old school addition, if you have 20 plus 11, we know that the answer to that addition problem is going to be 31. We're adding, so the operation is important. We identify the operation as addition, and the numbers on either side of that addition are both positive. So we're adding, and they have the same sign, so you just add the values, and notice that I'm not writing anything out in front, but 31, we kind of understand as being positive 31. You just leave off the sign. So because both numbers are positive, our final answer is going to be positive. Okay. Let's take a look at example A now. So we're adding, and notice what numbers are we adding? Well, we're adding a -11, and we're adding a -15. So the two numbers that we're adding both have the same sign. So according to our rules for addition, we add the absolute values, or the values of the numbers. 15 plus 11 is going to give us 26. Because both numbers were negative, that means our answer is going to be negative. So the answer is -26. If you want kind of like an interpretation for this, think about it like this. Suppose you owe one friend $11, and now you borrow or owe another friend $15. How much would you owe altogether? Well, you have a total of 11 plus 15, or $26 that's owed, i.e. -26. If we take a look at part B here, again, we want to identify the operation first. The operation is addition, and the numbers that we're working with are -2 and -8. Those two both have the same sign, so we're going to add them together. 8 plus 2 gives us 10. And then we keep the common sign. So final answer is going to be -10. So adding same signed integers, you add the values, the absolute values, and then you keep the common sign for the final answer. We're now going to look at the case where we're again adding integers, but now the numbers are going to have different signs, meaning it's going to be one positive and one negative. In order to add numbers that have different signs, what we're going to do is subtract the number, the smaller in absolute value, from the greater absolute value. So we actually subtract, and then we're going to take the sign of the number that was greatest in absolute value as the sign of the sum. Okay. For example, let's look at 2. Here we're adding again, and if we look at the numbers that we're adding, notice that they're different. We have a negative number and a positive number. So when we add, when the signs are different, what we do is we take the smaller value away from the larger value. So negative 13 in absolute value is 13. 4 in absolute value is 4. So we take the smaller away from the larger, and that would give us a value of 9. So the value for the answer is going to be 9, but now we have to attach the appropriate sign. The number that's larger in absolute value is the negative 13, right? 13 dwarfs 4, and because the 13 was negative, that means that the 9 for our answer is going to be negative as well. Let's look at the next one. Again, identify the operation first. We're adding, and the numbers have different signs. So we're going to subtract the values. I take the smaller value, which is 29. Excuse me, 6, which is smaller, which is sorry. Take the smaller value, which is 6 in absolute value, away from 29, and we get 23. So the value of our answer is going to be 23, and we now have to attach the sign of the number that's largest in absolute value. If we're just looking at sheer magnitude, 29 is bigger than 6. Because the 29 was positive, that means our answer is going to be positive. I just put the positive sign there for effect, but you don't have to include it. Final answer, 23. Let's take a look at part C. Here we're adding, and again, the signs are different. So you take the smaller value away from the larger value, and we get a value of 7. We now go back and see, well, which number was larger in absolute value? Well, 20 is bigger than 13. Because the 20 was negative, that means our final answer is going to be negative as well. When it comes to adding with signed numbers, if you want to think of like a real-world application, if it helps, you can think of negative integers as being like money that you owe somebody, and positive values is like money you actually have on you or money you have access to. And then if you operate under the rule that you always want to pay off your debts, notice in this example here, if you owe somebody $6 and you have $29 yourself, you can pay off that person the $6 that you owe them. That's going to take away from some of the money that you have, and you're going to be left with what? $23 for you at the end. If I come over here, for example, let's suppose we're in this situation right here. Suppose you have $13 that you have, but you also owe a friend $20. What would happen in this case? Well, you would pay or subtract off $13 of your debt. So you would pay that person $13. You would have no physical money left, but you would still what? At the end of that, you'd still owe them 7. So that would be negative 7. We now come to the definition of subtraction. And to subtract, it's really the same thing as addition of the opposite. Some people might have heard the phrase keep, change, change. But anytime we run into a subtraction operation with integers, we're going to do two things. We change the operation of subtraction to addition by changing the sign of the number behind it to its opposite. So sometimes you'll hear subtraction being referred to as addition of the opposite, and this is good for us because instead of having to memorize an entirely different set of rules for subtraction, all we need to do is take any subtraction problem, rewrite it as addition of the opposite, and then we can do this addition problem by using the rules of addition that we just talked about. For example, in 3 part A, we're asked to do 7 subtract 10. In order to do this subtraction, let me rewrite it first. I'm going to change the subtraction to addition by changing the sign of the number that's behind the subtraction. What's behind the subtraction is the number 10, which is positive. If I change 10 to its opposite, then that will give me negative 10. Now we have an addition problem where we're adding and the signs are different. So we subtract the smaller value from the larger value, which gives us 3. And we attach the sign of the number that was largest in value. 10 is a bigger number than 7. Because the 10 was negative, that makes our final answer negative. Let's come over to example 3. Again, the operation is subtraction. So I'm going to change this to addition of the opposite. The number that's behind the subtraction is the number negative 6. That's going to change to a positive 6. We now do this addition problem. We're adding and the signs are the same. They're both positive, so we just add the values and keep the common sign. So final answer, positive 11. With part C, we look at the operation. Again, the operation is subtraction. We want to change this to addition of the opposite. The number that's behind it is a negative 3. We change that to its opposite, which is now going to make that positive 3. We have an addition problem, so we're now going to do this addition. We're adding, and our numbers have opposite signs. So we take the smaller value away from the larger value, which gives us the value 6. The number that was biggest in absolute value was the 9, and because it was negative, that makes our final answer negative. The next thing we're going to do is kind of a longer type problem. We're going to simplify a series of additions and subtractions by changing all of these subtractions into additions. The easiest way, instead of necessarily having to do left to right, is you can then kind of group them and add all of your positive numbers together, add all of the negative numbers together, and then add those final two positive and negatives. Okay. So let's take a look at example 4. If I look at this problem, there's a bunch of different operations. Here's a subtraction, and here's a subtraction, and here's one as well. Let's begin by changing everything to addition. This is now going to be 7 plus, I need to change the opposite of negative 5. That's going to become positive 5. I now need to change this subtraction operation to an addition by changing 11 to its opposite. So that's going to be negative 11. This subtraction here I need to change to a positive by taking the opposite of negative 6, which is positive 6. And we now need to change this subtraction to addition by changing the positive 19 to its opposite, which is negative 19. Now that we've done this, we have a problem that only involves addition. Let's add the like types together. So I'm going to add my positive values over here. We have 7, 5, and 6. 7 plus 5 plus 6, because they all have the same sign, I can add them up and keep the answer positive. 7 plus 5 is 12, plus 6 would be 18. I can also go ahead and add my negative values together. Negative 11 plus negative 19, because they're both negative, I can add their values. It's going to give us 30. And we keep the common sign, which is negative. So we group them into like types. And now at the very end, we can do our last addition, which is to add these unlike types. We're adding a positive number and a negative number, so they're different. So the rules say you subtract the smaller value from the larger value, which would give us 12. Because the larger value in absolute value would be the 30, and it was negative, that makes the final answer of 12 negative. So a final answer for this one, negative 12. The next thing we come to is the rules for multiplication and division, and these will be very similar. The rules for multiplication say the following. If we multiply two real numbers and the signs are different, meaning one of them is negative and the other is positive, then the final answer will be negative. If we're multiplying two numbers together and they have the same sign, then the answer will be positive. So negative times positive, or a positive times a negative, that will result in a negative final answer. If both numbers are either both positive or if they're both negative and we're multiplying it, that will result in a positive final answer. The other important property of multiplication we want to talk about is the number 0. If you multiply any number by 0, it works out to be just 0. So 0 times anything is 0. And then, of course, just multiply the values as we know. In example A, we have positive 6 times negative 3. So the answer is going to be negative because it's one of each type. They have different signs. And then 6 times 3 gives us 18. So final answer, negative 18. In part B, we have negative 5 times 7. We're multiplying and the signs are different, so the answer is going to be negative. 5 times 7 is 35. Over here for part C, we're multiplying and the signs are the same, so our final answer is going to be positive. So I'm just going to put the plus sign to kind of remind myself. 9 times 10 is 90. So final answer is 90. And then lastly, over here for part D, we are going to multiply these two together. Notice that if one of the factors is 0, then the final product will be 0, because anything times 0 is 0. The next thing we're going to look at is multiplying more than two numbers. One of the ways you could do this is just kind of an order of operations style approach, where you multiply the numbers going 2 at a time, going from left to right, taking your answer, then timesing by the next factor in the multiplication. A faster way to do this is just to kind of determine the sign up front and then just multiply the values. If you have a product that has an even number of numbers in it, then has an even number of negative numbers, then that final answer is going to be positive. And the reason for this is if you have an even number of numbers in your product, then that means that you can kind of pair up the negatives. And within each pair of negatives, we know a negative times a negative will be a positive, and therefore the final answer will end up being positive. However, if you have a product that has an odd number of negatives, then it's not divisible by 2, and you're going to ultimately have one negative factor left over at the end, which will make the final answer negative. Okay? And of course, if any factor in your product is 0, then that will make the entire answer equal to 0. Let's use this technique to help us with example 6. If I look at this product, we have negative 3 times negative 1 times 2 times negative 2. I have an odd number of negatives. Right? I have 1, 2, 3 negatives altogether, which is an odd number. So that tells me that the final answer is going to be negative. Now that I know the sign, I'll put the negative sign down. All I have to do is multiply the factors together. 3 times 1 is 3. 3 times 2 is 6. 6 times 2 is 12. So the final answer for this one should be negative 12. If I look at example B, I have 1, 2, 3, 4. So for this one, I have 4 negative factors, which is an even number. So that tells me that my final answer for this one is going to be positive. So I'm going to put the plus sign just to remind myself that it's a positive answer, and then just multiply your factors. 1 times 2 is 2, 2 times 2 is 4, 4 times 3 is 12, and 12 times 4 is 48. So for the final answer on this one, it should be positive 48. Let's take a look at the next part, division of two real numbers. The rules for division are exactly the same as that for multiplication. If you're dividing and they have different signs, the answer will be negative. If you're dividing two real numbers and they have the same sign, then the answer will be positive. We also have a special case in this situation, two different special cases for division. If you have a 0, if you're dividing into 0 by any non-zero number, the answer will be 0. So 0 divided by anything that's not 0 equals to 0. On the other hand, if you try to divide by 0, this is what we call undefined. So in mathematics, division by 0 is undefined. Let's take a look at example 8. We want to do 8 divided by negative 2. We're dividing. The signs are different. So the final answer is going to be negative. 8 divided by 2 is 4. So final answer is going to be negative 4. If we look at part B, negative 36 divided by negative 4, we're dividing. The signs are the same. So the answer is going to be positive. 36 divided by 4 is 9. So final answer, positive 9. For part C, we have 13 divided by 0. Again, if you're trying to divide by 0, that's the operation that's undefined. But on the other hand, if we try to take 0 divided by -7, anything dividing into 0 that's non-zero will be 0 itself. Let me quickly explain why division by 0 is undefined. And I'm going to do so with an example here. Let's suppose, I know this is going to sound really silly, but just kind of bear with me. If I said, what is 10 divided by 2? All of us would look at this and be like, oh, I know the answer is 5. Well, the question is, why is the answer 5? Well, when you take 10 and divide it by 2, you're essentially asking yourself the question, what do I need to multiply by 2 in order to get 10? And of course, that makes that answer 5. Let's then see if we could try, let's try it. Well, what happens if I try to divide 10 by 0 then? Well, the same thing. You're looking for a number such that when you multiply it by 0, you get 10. The problem with this is that we know that 0 times anything, doesn't matter what you pick for that number, 0 times anything is equal to 0, right? It will never, ever end up giving us the value 10. And that's exactly why division by 0 is undefined.